Unseen entities may coexist with our reality, composed of undetectable matter. These entities exist not in distant locations, but in the same space we occupy. The composition of these entities is fundamentally different, rendering them undetectable by conventional means. The universe is composed of stars, planets, and galaxies. Visible matter accounts for only about 5% of the universe's total composition. Modern cosmology estimates that the majority of the universe consists of dark matter and dark energy. Dark matter constitutes approximately 27% of the universe's composition. Dark matter is an invisible form of matter that neither emits nor absorbs light. Dark matter's invisibility renders it undetectable through electromagnetic means. Dark matter's presence is inferred through its gravitational effects on visible matter. Galaxies rotate faster than expected based on the visible matter alone, suggesting additional unseen mass. Light bending around empty space also indicates the presence of dark matter. Dark matter's gravitational effects on visible matter suggest the presence of a significant unseen mass component. The observed behavior of galaxies implies that dark matter constitutes a substantial portion of the universe's total mass. Scientists infer the existence of dark matter based on its impact on the movement and structure of observable cosmic objects. Dark matter may constitute a significant portion of the universe's total mass energy density. Dark matter could potentially form structures and evolve over cosmic timescales. Simulations are essential for understanding the potential structures formed by dark matter. Dark matter may possess its own unique form of chemistry, distinct from known atomic interactions. Hypothetically, dark matter chemistry could support biological processes independent of carbon-based life. The existence of dark matter life would represent a fundamentally different form of biological organization in the universe. A hypothetical dark matter biosphere could exist, interpenetrating our own without direct interaction. This dark matter biosphere would be composed of particles and forces beyond our current understanding. Its existence would have no observable impact on our world due to the lack of interaction between normal and dark matter. Some physicists propose the existence of particles that interact within the dark matter realm. These interactions allow dark matter to clump together, forming bonds and building structures. The clumping and bonding of dark matter particles may explain the formation of larger cosmic structures. Dark matter may form stable structures, potentially leading to the creation of molecules. These dark matter molecules could arrange themselves into complex structures. Hypothetically, dark matter arrangements might even mimic the complex structure of DNA. The potential for dark matter to form life represents a speculative yet intriguing scientific possibility. Simulations explore the hypothetical self-organization of dark matter into complex structures analogous to biological organisms. The properties of dark matter could theoretically allow for the emergence of life forms with fundamentally different characteristics than ordinary matter. The concept of dark matter intelligence explores the potential for intelligent life forms existing within dark matter. Dark matter intelligence could operate on principles fundamentally different from those governing biological intelligence. Hypothetical dark matter neural networks might utilize gravitational interactions for information processing and communication. The hypothetical existence of dark matter life suggests the potential development of unique civilizations. Dark matter civilizations could possess technologies fundamentally different from those known to baryonic matter. Simulations offer a glimpse into the possible structures and dynamics of these unseen dark matter cities. Hypothetical dark matter beings may possess spacecraft constructed from materials undetectable by current scientific instruments. These beings could potentially form societies structured around interactions and technologies based on principles beyond our current understanding. Art created by dark matter beings might utilize forms and materials that are imperceptible to human senses and detection methods. The search for extraterrestrial signals may overlook the possibility of coexisting civilizations on different planes of existence. Dark matter civilizations could potentially share our space without interacting through conventional means. These civilizations would exist on a different plane, undetectable by our current methods of signal detection. Dark matter's interaction with ordinary matter is so weak that it passes through objects unnoticed. The laws of physics themselves conceal the existence of dark matter, rendering it effectively invisible. Hypothetical dark matter beings could coexist with us, their presence masked by their non-interaction with ordinary matter. Hypothetical dark matter beings could potentially observe us without our awareness. These beings might construct their cities interdimensionally, existing within and through our own. Our perception is limited, potentially preventing us from detecting these parallel existences. It is conceivable that hypothetical dark matter entities possess sensory capabilities beyond human comprehension. These entities might have already detected our existence through means undetectable by current scientific instruments. The nature of dark matter perception remains speculative, involving theoretical interactions with gravity or other fundamental forces. Scientists employ underground detectors in an attempt to directly detect dark matter particles. Underground placement shields, detectors from cosmic rays and other background radiation. Particle colliders represent another approach to indirectly study dark matter through high-energy collisions. Despite significant efforts, direct detection of dark matter has proven elusive. Advanced data analysis and visualization techniques are employed to identify potential dark matter signals. The low interaction rate of dark matter particles poses a major challenge for direct detection experiments. Dark matter can be conceptualized as an ecosystem rather than solely through the lens of physics. This ecosystem model allows for the application of ecological principles such as competition and symbiosis to dark matter interactions. Viewing dark matter as an ecosystem offers alternative approaches to understanding its behavior and distribution in the universe. Unexplained anomalies in quantum fluctuations could potentially indicate the presence of dark matter life. Anomalous gravity waves might also serve as traces of dark matter life. These traces offer potential pathways for detecting and understanding dark matter lifeforms. Exotic theories suggest dark matter interacts via distinct fundamental forces. These unique forces may create a shadow universe, governed by different physical laws. The shadow universe operates under rules distinct from those governing our observable universe. In a shadow universe, intelligent life may evolve without the need for light. Such life forms might not perceive or require heat as a source of energy or environmental regulation. The concept of time, as humans understand it, may be irrelevant to the existence and evolution of these life forms. The discovery of dark matter life would revolutionize our comprehension of our position in the universe. Our current cosmological models would require substantial revision to accommodate dark matter-based life forms. The existence of dark matter life suggests the possibility of vastly different biological and physical laws governing other parts of the cosmos. The universe may contain forms of matter and energy far more abundant than what is visible. Dark matter and dark energy could represent a dominant, yet unseen, component of the cosmos. The true nature and scale of dark matter remain a significant mystery in modern astrophysics. Human awareness of the universe may be fundamentally limited. The scale of the universe dwarfs human perception, creating inherent constraints. Analogously, ants on a sidewalk are unaware of the city and human civilization. Dark matter entities may exist with a complete indifference to humanity. The indifference of dark matter beings suggests a lack of interaction or concern for our existence. Alternatively, dark matter beings could be observing humanity without intervention. The hypothesis suggests the possibility that our reality is part of a larger experiment. Dark matter beings may be conducting this experiment, to study the evolution and behavior of our universe. This experiment explores fundamental questions about the nature of reality and the potential for manipulation by higher dimensional entities. Hypothetical communication from dark matter beings might be imperceptible to human senses. Fundamental differences in physics or information encoding could prevent understanding. Our current communication tools and methods may be inadequate for such alien contact. Whispers may represent a form of communication that remains beyond human comprehension. Sound waves, even at the faintest levels, carry potential information that is not readily decipherable. The subtle nuances within a whisper's sound wave may contain encoded or unrecognized messages. Messages may be encoded within the fabric of gravity itself. Time, as a dimension, could also serve as a medium for encoding information beyond our current comprehension. Advanced methods of encoding may exist beyond our current understanding of physics. Dark matter represents a significant limitation in our ability to directly perceive the universe. Our current understanding of the universe is incomplete due to the elusive nature of dark matter. The inability to directly observe dark matter highlights the inherent limits of human perception and scientific instrumentation. The limitations of human perception may restrict the understanding of existence. The extent of reality beyond human sensory capabilities remains unknown. The fundamental question is not about the existence of the external world, but about the degree to which we can perceive it. Life may exist in various forms, not all of which are composed of detectable matter. The diversity of life forms extends beyond our current understanding and detection capabilities. Hypothetical life forms could exist as energy fields or within dimensions beyond our sensory perception. In the vast silence of space, the perception of emptiness may be misleading. The universe suggests that we might be surrounded not by nothing, but by someone. The concept of someone implies an interconnectedness and potential for interaction within the vastness of space. The concept of being alone is questioned by the potential existence of unseen life forms. Conceptual isolation is challenged if unseen life coexists. The definition of alone evolves with the possibility of undiscovered coexisting life. The observable universe represents only a small portion of the entire cosmos. Current technological limitations restrict our ability to detect light from distant regions. The universe's expansion rate continuously increases the distance to the most remote objects. Human senses perceive only a limited portion of the electromagnetic spectrum. The electromagnetic spectrum encompasses a wide range of frequencies and wavelengths, far beyond human vision. Visualizing the full electromagnetic spectrum reveals the narrow scope of human sensory perception. Dark matter's presence can be revealed by observing how it bends light from distant objects. Gravitational lensing occurs because massive objects warp spacetime, causing light to follow curved paths. The degree of light bending depends on the mass of the lensing object and the alignment of the source, lens, and observer. Galaxies rotate at speeds that defy predictions based on visible matter alone. Observed rotation curves deviate significantly from theoretical curves calculated using only luminous mass. The discrepancy between observed and theoretical rotation curves suggests the presence of unseen mass. One theory proposes that dark matter is composed of weakly interacting massive particles, WIMPs. WIMPs are theorized to interact through the weak nuclear force and gravity. The WIMP theory attempts to explain the nature and composition of dark matter. Actions are proposed as hypothetical elementary particles that could constitute dark matter. The axion is a leading candidate to explain the composition of dark matter. Actions are extremely light and weakly interacting particles, making them difficult to detect. Sterile neutrinos are hypothesized particles that interact very weakly with matter. The elusive nature of sterile neutrinos makes them difficult to detect directly. Sterile neutrinos are considered as potential dark matter candidates due to their weak interactions and abundance. MACOs, or massive compact halo objects, are potential constituents of dark matter. Black holes are one type of macho that could contribute to dark matter. Macos are massive, compact objects located in galactic halos. Dark matter particles may possess the ability to interact with each other through self-interaction. Simulations are used to model and study the potential interactions between dark matter particles. Understanding self-interacting dark matter can help explain the distribution of dark matter in galaxies. Dark photons are hypothetical particles that could mediate interactions within the dark sector. These force carriers are theorized to interact with dark matter, similar to how photons mediate electromagnetic forces in the visible universe. The existence of dark photons could explain various phenomena related to dark matter and dark energy. Mirror matter theory proposes the existence of a parallel universe. This parallel universe interacts with our own through gravitational forces. The interaction suggests a hidden dimension influencing both universes. A fifth force is a hypothetical fundamental force beyond the known four: strong, weak, electromagnetic, and gravitational. The existence of a fifth force could potentially explain the behavior of dark matter. The properties and interactions of a fifth force remain largely unknown and are subject to ongoing theoretical and experimental investigation. Modified Newtonian dynamics, MOND, is an alternative gravity theory that challenges the need for dark matter. MOND modifies gravity to explain observed galactic rotation curves without requiring dark matter. MOND proposes a modification to Newtonian gravity at very low accelerations. Fuzzy dark matter exhibits wave-like behavior at small scales. Unlike traditional cold dark matter, fuzzy dark matter forms interference patterns. The wave nature of fuzzy dark matter affects the formation of small-scale structures. Warm dark matter particles possess intermediate speeds. The speed of warm dark matter particles is between that of cold and hot dark matter. Intermediate particle speeds influence the structure formation of galaxies. Cold dark matter is composed of particles that move at relatively slow speeds. The slow movement of cold dark matter particles influences the formation of cosmic structures. The cold in cold dark matter refers to the low kinetic energy of its constituent particles. Hot dark matter consists of particles moving at relativistic speeds. The high velocity of hot dark matter particles prevents the formation of small-scale structures in the early universe. Examples of hot dark matter candidates include light neutrinos. Dark stars are hypothetical celestial objects powered by dark matter annihilation rather than nuclear fusion. Dark matter annihilation within a dark star's core releases energy, sustaining the star's luminosity. Unlike conventional stars, dark stars derive their energy from dark matter, a non-baryonic form of matter. Dark matter forms halos that surround galaxies. These halos are composed primarily of dark matter, an invisible substance that interacts gravitationally. The gravitational influence of dark matter halos affects the structure and dynamics of galaxies. The bullet cluster is formed by the collision of two galaxy clusters. The hot gas in the bullet cluster is separated from the galaxies due to ram pressure during the collision. The distribution of dark matter, inferred through gravitational lensing, does not coincide with the hot gas, providing evidence for its existence. The cosmic microwave background, CMB, is remnant radiation from the early universe. The CMB's properties support the dark matter paradigm. Analyzing the CMB provides insights into the composition and evolution of the universe. Dark matter plays a crucial role in the formation of the universe's large-scale structure. Simulations reveal how dark matter's gravity influences the distribution of galaxies. The cosmic web, shaped by dark matter, guides the arrangement of galaxies into clusters and superclusters. N-body simulations are used to model the distribution of dark matter. These simulations track the gravitational interactions of numerous particles to predict the structure of dark matter halos. The resulting models help scientists understand the formation and evolution of galaxies. Direct detection experiments aim to observe interactions between dark matter particles and ordinary matter. These experiments use sensitive detectors to identify the faint signals produced by dark matter interactions. Xenon detectors are designed to minimize background noise and maximize the probability of detecting rare dark matter events. Indirect detection experiments search for annihilation products. Gamma-ray telescopes are used to visualize the results of indirect detection experiments. Annihilation products are identified through gamma-ray detection. Collider experiments aim to produce dark matter particles through high-energy collisions. These experiments replicate conditions similar to those shortly after the Big Bang. Detectors surrounding the collision point record the properties of newly formed particles. The Dama Libra experiment has controversially claimed the detection of dark matter. The nature and validity of Dama Libra's dark matter detection claim are subjects of ongoing scientific debate. Independent verification and alternative explanations for the observed signal are crucial for confirming dark matter detection. CREST, or Cryogenic Rare Event Search with Superconducting Thermometers, employs cryogenic detectors. Cryogenic detectors are essential to the CREST experiment. CREST aims to detect rare events using extremely sensitive cryogenic detectors. Lux Zeppelin LIZ is a dark matter detector that uses liquid xenon. The LZ experiment aims to detect dark matter particles through their interactions with xenon atoms. Liquid xenon provides a dense and ultra-pure medium for sensitive dark matter detection. PANDAX is a xenon-based experiment. PANDAX stands for Particle and Astrophysical Xenon Detector. PANDAX utilizes xenon to detect particles and astrophysical phenomena. Super CDMS utilizes cryogenic detectors in the search for dark matter. Silicon and germanium are the primary materials used in Super CDMS detectors. Cryogenic temperatures are essential for the high sensitivity of Super CDMS detectors. ADMX, the Axion Dark Matter Experiment, is designed to detect axions. The experiment aims to identify axions, hypothetical particles that may constitute dark matter. ADMX employs advanced technology to search for faint signals produced by axion interactions. The CERN Axion Solar Telescope, CAST, is designed to detect axions originating from the Sun. CAST searches for axions by converting them into detectable X-rays using a powerful magnet. The telescope is aligned to track the Sun, maximizing the potential detection of solar actions. Fermi-LAT is a gamma-ray space telescope designed to detect high-energy radiation. The primary mission of Fermi-LAT involves searching for gamma rays produced by dark matter annihilation. Detecting gamma rays helps scientists understand the nature and distribution of dark matter in the universe. AMS-2, the Alpha Magnetic Spectrometer, is designed to measure cosmic rays in space. The primary function of AMS-2 is to precisely detect and analyze high-energy cosmic particles. By measuring cosmic rays, AMS-2 provides data for understanding the origin and nature of dark matter and antimatter. Integral is a gamma-ray observatory. Integral observes gamma rays. Gamma-ray observation provides insights into high-energy astrophysical processes. Future experiments are designed to achieve increased sensitivity in detection. Next-generation detectors aim to improve the precision and accuracy of experimental results. Enhanced sensitivity enables the detection of subtle signals and rare events. The search for dark matter challenges existing cosmological models. Understanding dark matter may require revising fundamental assumptions about the nature of the universe. The existence of dark matter prompts a re-evaluation of humanity's understanding of its place in the cosmos.